This is the setup for the predicting acceleration from coefficient of friction activity. The purpose of this activity is to be able to use what we know about how the force of friction and the coefficient of friction and the normal force, how they go together with that formula, and how the angle of a ramp affects the force down the ramp and the normal force into the ramp, and tie all that together and be able to make a prediction about how fast an object is going to accelerate up a ramp. So this is a multi-step problem. There's not a lot of data to collect. It's a capstone lab activity, so I'm going to expect you to be able to figure out which equations to use. My notebook will walk you through the order you need to, at least one order that will work, that will allow you to solve this problem. But I expect you to be able to I expect you to be able to figure out which equations to use. So the key points of this setup, one is so we don't chip the floor. We've got a book sitting underneath the weight that we're hanging right now. I have a light enough weight that it's not heavy enough to pull my block with the weight on it. You'll start with a 0.5 kilogram or 500 gram weight taped on top of a block. You put the wooden side down against the wood so it's wood on wood. You will make sure the string, you can't really see the string, is parallel to the board. And this is a 10-degree angle. Mine's actually 9 degrees, but actually you're going to start with a 15-degree angle. So you're going to do 15 degrees and 35 degrees. In my data that I give you, I used 9 degrees and 30 degrees. You'll use slightly different data, so your numbers will be close, but they won't quite match mine. As an overview of what we're going to do, we're going to put a weight on here. You're going to put 400 grams or 0.4 kilograms, and you're going to use your LabQuest to measure the acceleration of the block up the ramp. From that, you should be able, through 2 or 3 steps, a few steps, to calculate what the coefficient of friction is between this block of wood and the ramp. Then we're going to change the angle. I'll raise it up to 35 degrees. I'll show you that setup in a minute. To do the 35 degrees will look like this. So it'll be much steeper. Then we'll be able to predict. Before you run the experiment, you'll do the calculations to figure out what the acceleration will be for the new block. And then you'll run the test and see if your prediction is correct. Here's a close-up view of the weight with the block of wood with the weight attached to it, and you notice the string should be parallel to the board. Here's a quick example of how you would collect the data. The first thing you do is you hit the play button. Remember, you can go, all of you I think know how to do this now. Remember, you need to set the LabQuest on pulley. Make sure it's on pulley or your data will be messed up. So then I hit the green play button, and then I just hang the weight on there, and the LabQuest will do all of the work for me. So just hang the weight. Shouldn't go down too terribly fast. One nice thing about this, it doesn't crash, because once the weight hits the ground, the block of wood just sits on the ramp. You'll collect data the same way at the 35-degree angle. Press the green play button. You can just hang the weight, but it was just me, so I had the weight sitting here. And then you drop the weight and you measure the acceleration. Just like we did before, and again, you have the book in case the weight goes down too fast, so you won't chip the floor. And that's all there is to it. So there's not a lot of complicated data collection. There's not a lot of data, but there is going to be some computation that you need to figure out and make your prediction. Let's look at the lab notebook next. Good luck. Let's walk through the notebook entries for predicting acceleration from a coefficient of friction. I expect to see this diagram in your notebook, and this diagram. These both represent the same things. The diagram on the left gives you a better picture of physically how you have the equipment set up. The diagram on the right is a force diagram that only deals with the forces. If I think of M1 and M2, these two weights are connected with a string, so I can think of them as one object. That one object has a force pulling to the right, in this case, force of gravity just from M2. So this Fg is just the Fg from the second mass. The M1 has two forces pulling. The total M1 plus M2 has two forces pulling. The friction is pulling to the left, and the force we've called FH, the horizontal force down the ramp, is pulling to the left. And we have equations for all of that. Give you a hint. Equation number 1 is the net force equals MA, and equation number 2 is the net force equals FGM2, that's the force of gravity, minus the other two forces. So I take this force minus these two forces gives me the net force. So you should be able to substitute those two. The data I used, if you want to check your calculations, was the angle was 9 degrees, my mass 1 was 0.64 kilograms, and you can read that. And this is what I measured when I did the first part of the experiment. Like we saw earlier in the video, all you do is I let this weight go, and I let the LabQuest gave me this acceleration of 1.48 meters per second squared. From that information, I could find the net force, I could find the force of gravity pulling down, I could find the horizontal force down the ramp. From those three forces, I could find the force of friction. I also have a formula for the normal force. That's the normal force up here of M1. From that, I have an equation which allowed me to find the coefficient of friction for sliding, because that's what we measured. The acceleration was telling us how fast we were moving. We did that while we were sliding, so it's mu k. So that's part 1. The whole first part of the lab is to take all this data and find the coefficient of friction. So I did a new angle of 30 degrees. You're going to use 35 degrees. My M1, I added 500, so in other words, I now have the block and 1 kilogram. So before I had the block and a half a kilogram, now I have the block and 1 whole kilogram. So I have 1.14 here, whereas before I had 0.64. And you will also do that. You will also have M2 equal to 1 kilogram. And then from above, I already know my coefficient of friction. From that, I can calculate my force of friction. I can still calculate my force of gravity on the M2 weight. I can find the force pulling down the ramp. And from that, and the fact that using from this information, I can now find what my acceleration should be. Then I ran the experiment, and I found my percentage difference. So this is a lab that should be able to get you some really accurate data. I would hope that everybody can be under 5% on this lab. Good luck.